This is the second unit of STM subject, transaction flow testing. It includes transaction flows, transaction flow testing techniques. Let the flow of transactions not valid or not individual statements. Transaction related concepts are included in transaction flow testing chapter. Steps of a transaction flow. First we will go for testing, like identify all transactions like login, withdrawal cash, transfer money. For which concept, for which content, you need to identify the transaction, then draw transaction flow graph. Then you need to draw the flow graph, identify all possible transaction paths. If it has a paths, then you need to identify all transaction paths, normal paths, alternative paths, error paths. You need to identify them separately. Then go for designing test cases for each path. Then draw each test case path. Then execute tests and analyze the results. Then execute the test and you analyze the results. Like example, ATM system. Transaction is the process of sending money, debit and credit. Cash withdrawal, like a flow. Insert a card, first step. Then you need to enter the PIN. After that you need to select the window, on which window you are performing the task. Then enter amount. After that check balance. Then after dispense cash. Then print receipt. These are the steps involved for transaction flow. This is the transaction flow. Then application of this concept, banking systems, e-commerce websites, online registration systems, ticket booking systems. For all these cases, we use this transaction concept. Advantages of doing this concept is testing real world usage, covers business logic, easy to understand this transaction concept, effective for system and acceptance testing. These are the advantages of transaction. We have some limitations or drawbacks or disadvantages. These three are same. Internal code logic not tested, large systems, many transaction paths not suitable for unit testing. These are the disadvantages of transaction. Then we are going to discuss now transaction flow testing technique. It is a black box testing method used to test business transactions or functional flow of an application. A transaction is a sequence of operations performed by the system in response to a user requirement. Like it is the purpose of a transaction, like a business purpose or a functional flow of an application. Transaction flow graph. We have some key points like nodes, edges, paths. These three key points we use for transaction flow graph. Nodes are the processing steps from where to where the transaction is happening. Edge, flow of control, is known as edge. Path, complete transaction, is the path. Technique, same as transaction flow testing, we have 5 steps. These are the 5 steps. 1, 2, 3, 4, 5. These are the 5 steps we use in transaction flow graph. After that, data flow testing. It is a white box that focuses on variables, definitions, uses, detection of data, related defects. These are the terms we use in transaction. Purpose, detect uninitialized variables, detect unused variables, detect incorrect variables usage. These are the purpose of introducing this concept. Key concepts: variable gets a value, variable is used to computational use like a C use, used in calculations. Predicate user is P user, used for conditions. Basics of flow testing. It is a white box testing technique. It mainly focuses on control flow, logical flow, and execution sequences. Like how the flow is happening in testing is known as a flow testing. In a program, logic is correctly implemented. Flow graph. It is a concept of representing logical structure. Flow graph format of a program. Components like nodes, edges are used for linking. Decision nodes, like nodes with more than one outgoing edges is known as decision node. And region. These are the flow graph concepts. Then we will go for purpose of flow graph. We have 5 steps. Verify correct program logic. First we need to verify. Then after we need to detect or find logical errors. Then identify the unreachable code. If any code is not reached for execution, then we need to identify it. Then improve test coverage. It should cover all the lines of a code. Ensure path correctness. Check the path is correct or not. These are the steps, purpose of a flow graph. Then we have some key points of this chapter is path. It is a sequence of nodes from entry to exit. Independent path. It does not depend on any value or any path or region. Introduce at least one new edge. It will introduce one new edge. At least one new edge it is introduced. Predicate node. A decision making node like if else, while loop, for loop, like that. Path predicate like conditions that must be true for a path to execute is known as a path predicate. Types, we have some types of a path predicate like a statement testing. Every statement will be executed at least once. Every statement must be executed at least once, and then we will go for branching. For decision testing, we will choose this technique testing. Every transaction, every branch of decision executed. Branch testing is every branch should be executed. Path testing, all possible paths are to be tested. Like that. These two are similar. The difference is a branch and path. These two will be executed at least. These two should be executed. All possible execution paths to be tested in case of branch and path testing. Next concept is strategies in data flow testing. It is a data flow testing technique. It mainly focuses on testing and variable definitions, variable uses, the flow of data in a program. It is the responsibility of this all definitions strategy. For all variable definition, at least one use of the variable must be tested. Ensures variables are not defined and left unused. Advantages is it is simple and economical. Like it is easy to use, and this all definition strategy is for every definition at least one use of variable must be tested. All uses strategy. For each variable definition, all possible uses must be tested. The difference between all definition strategy and all user strategy is in case of all definition strategy, we will check for variable must be tested. In case of all uses strategy, all possible uses must be tested. All uses strategy. For each variable definition, all possible use cases must be tested. Here we have uses like two types, C use and P use. C is the computational, P is the predicate use. Advantages of this is more thorough than all definitions. Limitations, it requires more test cases. All C uses strategy like testing all computational uses. C is computational, P is predicate user, it is P use, it is C use. Computational uses of variables from each definition like arithmetic and assignment operators. For arithmetic like mathematics, addition, subtraction, multiplication, division. Assignment is taking plus symbol and equal symbol together, minus symbol and equal, like that, assigning two symbols at a time. It is z equals to x plus y. It is the C use of x and y. All P uses strategy. Test all predicate uses of variables from each definitions. Decision making conditions. For all DV paths strategy, D is the definition, V is the variable without a redefinition. The advantages of all DV path strategies is it is detects all data related anomalies, and a limitation of this is very expensive and complex. Application of data flow. First we need to detection of uninitialized variables. First we need to check the variables are all initialized or not. If not, we need to identify variables used before assignment. We need to identify before assigning the variable. Then we need to prevent the runtime errors. After the second step is to detection of unused variables. Unused variables, not using variables, should be identified. After getting uninitialized variables, then find variables that are defined with but never used, like third step. Second step is to helps like remove redundancy code. Third step is to detection of multiple definitions. Defects variables are defined repeatedly. It avoids logical errors and memory waste. The process of main advantage is this: avoids logical errors and memory waste. Identification of data flow anomalies, like helps to detect by these terms DD, DU, UD, UU. DD is double definition, DU is defined but unused, UD is used before definition, UU is used without definition. These are the terms used for identification. Then we need to improve program reliability, like ensuring correct data, taking correct data and values, flow between statements and reduces changes of incorrect output, like taking the correct values and decreasing the incorrect output. Sixth step is to useful in safety critical, applied in banking systems and medical software and aviation. It is used for medical software purposes, for safety critical systems, aviation and defense systems, program maintenance and debugging. It helps to understand variable usage and during during the process, helps to understand variable usage during code modification, enhancement, bug fixing. These are the values, these are the terms we need to maintain. Eighth step is to validation. Validation of compilers and optimizers used to check correctness of variables, handling, code optimization techniques, suggests or supports, then supports a regression technique. Ensuring changes in a code does not disturb existing data flow is known as supports a regression testing. Then after, we have some advantages of doing this method. Finds the hidden logical errors by using this method, and it improves the code quality. Then decreases or reduces future failures, enhances test coverage, domain testing. This is a separate concept. Domain and path. Domain is the set of input values for which the program follows the same execution path and produces similar behavior. Like each domain corresponds to one path of the program, and a change in input that changes the path means change of domain.